This video is presented to you by www.testprepadda.com. Dear students, you must be aware of the term solution. The study of chemistry is incomplete without the study of solutions. In our daily life, we come across many solutions, and their importance in life depends upon their composition. You must have heard about brass. It is a mixture of copper and zinc. You must have heard about bronze. It is a mixture of copper and tin. These two have different properties. One more example. 1 gram of fluoride ions in 10 to the power 6 grams of water, that we call as 1 ppm, is required to prevent the decay of the tooth. But if it increases to 1.5 gram per 10 to the power 6 gram of water, that is 1.5 ppm, it will cause tooth to become mottled. And if you increase the fluoride concentration further, it can be poisonous also. Dear students, from this session I will start the discussion of solution and different ways to express the concentration of solution. Now, what is solution? Here is the definition. Solution is a homogeneous mixture of two or more non-reacting substances. And here the meaning of homogeneous is the composition and properties are uniform throughout the mixture. If there are two components in the solution, it is known as binary solution. In binary solution, one component is called solute and another component is called solvent. Now if I take NaCl salt, if this NaCl solid is put in water, then the solution obtained will have physical state of liquid. Single phase here we are getting. Homogeneous. The composition is the same throughout the solution. If I put sugar in water, here also you are going to get a single phase. Throughout the solution, the composition of sugar will be the same. In this example, NaCl is mixed with water. In this example, sugar is mixed with water. So both these are the examples of binary solution. Dear student, in this chapter we will talk about only binary solutions. Here we have written that in binary solution, one component is solute and another component is solvent. Now question arises, in a mixture, how do we decide that which component is solute and which component is solvent? Now many of you, if I ask you what is solvent, you may say that solvent is that component which dissolves the solute. And if I ask you what is solute, you may say that solute is that component which is dissolved in the solvent. But when you are saying that solvent is that component which dissolves solute, so in your definition the term solute was not defined. The definition of definition is all the terms should be defined. When I asked what is solute, you said solute is that component which is dissolved in the solvent. Again, in your definition of solute, the term solvent is not defined. So, what should be the correct what should be the correct definition of solvent and solute. Now to understand the correct meaning of solvent, I will take an example of sugar solution. Obviously, sugar solution is a mixture of sugar and water. Basically, we are mixing sugar and water, and this way we get sugar solution. Now, if I ask you, what is the physical state of this sugar? You will say solid. What is the physical state of this water? You will say liquid. Now, what is the physical state of this sugar solution? You will say liquid. Now, the physical state of this sugar solution matches with the physical state of water. Now, if I take the example of salt solution, salt is mixed with water. For example, NaCl. Now, we will get salt solution. Again, if I ask you what is the physical state of this NaCl salt, you will say solid. What is the physical state of this water? You will say liquid. What is the physical state of this salt solution? You will say liquid. Now, what is the relation? In both the cases, we have seen that the solution physical state is the same as the physical state of solvent. Are you getting my point? So what is the conclusion? Solvent is that component of the solution whose physical state is the same as that of solution. But many times what happens, if you mix C2H5, that is liquid, with water, that is again liquid, and what will be the physical state of the solution? It will be liquid. So if the two components have the same physical states, then how to decide solute and solvent? Here I have written, if the two components have same physical states, then the component which is present in greater quantity is considered to be solvent. Students, let me tell you, the meaning of dissolution is when you put salt in water, water molecules will surround the salt particles. Water molecules will surround the salt particles. This is called dissolution, and this way solution is obtained. Now we have defined this solvent. Now easily you can say solute as that component which is dissolved in the solvent, because now solvent is defined. My point is clear? Dear students, component of solution can be in solid state, liquid state and gaseous state. And depending upon the physical states of solvent and solute, 9 types of solutions are possible. Let me show you. You can see here I have written the solution type: solid solutions, liquid solutions, gaseous solutions. When you say solid solutions, the meaning of this is your solvent is in solid state. When you say liquid solutions, means solvent is in liquid state. When you say gaseous solutions, means the solvent is in gaseous phase. My point is clear. Now, as I told you, 9 types of solutions are there. This is the first type. Your solute is in solid state. Your solvent is also in solid state. Example is alloy. Number 2, solute liquid state, solvent solid state. Example, amalgam, mercury in zinc, mercury in gold, etc. Now, Gas in solid. Gas in solid. Solution of hydrogen in palladium. Fourth, solid, solute and solvent, liquid. Example, salt in water, sugar solution. Fifth, solute is in liquid state and solvent is in liquid state, alcohol in water. If the solute is in gaseous form and solvent is in liquid state, this is the sixth one. Example, aerated drink. Seventh, solute is in solid state, solvent is in gaseous form. Example, camphor vapors in N2 gas. Eighth, solute is in liquid state, solvent is in gaseous state. Example, water vapors in air. Ninth, gas in gas means solute is in gaseous form, solvent is also in gaseous form. Example, air. My point is clear. So these are different types of solutions possible. Dear students, in the next video lecture, I will talk about the concentration of the solution, and I will talk about different ways to express concentration. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.